could get into Mensa, right? So here's what you do first. You graph the damn thing. Please, dear God, make a picture for yourself. I've had students that just for some reason could not do a normal curve, so I just said make a freaking triangle. All it's for is just to anchor things, so you get a feel for where things are. Right? So if you need to, you can go that far. I'm hoping you can kind of do a normal curve. Fat, skinny, I don't care. What goes right in the middle?
0.
Careful now. I agree with you in the point. The mean is 100. And the data point I want is 133. Now be careful, I always have people that just put 133 wherever they feel like it. Now, it can't go there. This is the number line. It's got to be up here somewhere, right? Now, where would the area be that I'm curious about? Shade in the area you want. That area, right? And that matches up with what I expect. If the average is 100 and standard is 15, I expect a very small percentage to be more than 133. Cool. And it really doesn't matter. As long as you put the 133 above, this is just to give me a mental preview of what to think about. Right? I need some kind of a visual. Why can I not use that chart yet to find areas, to find probabilities? Because that chart only works with more than just that. I mean, here's my positive one. Yay. But it only works with z-scores, right? So what kicks ass is, okay, that's not a z-score now, but we know how to make it into a z-score, right? What's the formula for a z-score?
It's the point minus the mean.
Yeah. So it's always minus the mean. That comes second. If you turn it around, your z-score suddenly is the wrong sign. My data point that I'm curious about, minus the mean divided by
Standard deviation.
standard deviation. Standard deviation. Is that 2.2? Yeah. And of course, now you see, why do you always round z-scores to 2 places? Because the chart goes out to 2 places, right? That makes sense. Can't beat that. So if I look up 2.2, what do you guys find when you look up 2.2 up? Probably beautiful. The minute you look up, and in fact, let me be really careful. I want to get you guys on the right path from the beginning. Always the mean is in the middle. Put your data point or data points that you're curious about. Underneath here, put the z-score that you got. When I took stats, my teacher made us draw 2 separate pictures, one for the raw scores and one for the z-scores. I'm like, screw that crap. It's the same picture. The minute you look up a z-score, put it in the right place. Where is that 9861? Where is that? Yeah, it's this way, right? In fact, the chart tells you whatever you look up, it's the area below that.
Wait, why do you have the 0 underneath the 100?
Oh, what's the mean always become as a z-score? Z-score is how far from the mean I am, and the mean is 0 away from itself. Cool. So this is the area we just looked up, right?
Yeah.
0.9861. That's not the answer to my question. That's another reason why you have this picture, so you can make sure you actually answer the question. The people that don't draw the picture, most of them will give me this as the answer and go on. But if you draw the picture, like, well, screw that, that's not the answer. How do I get the answer? It's not this much, it's the rest, right? The whole thing is what? 1. If that's 0.9861, how do I get what that is? 1 minus that, right? There you go. Right? So 1 minus that side should be this side. And to subtract some decimal from 1, you actually just make them all 9.013 and make the last one 10. Or you just put in a calculator. Yeah?
So how would a problem like this be phrased? I mean, would you say I want positive?
It could either be as nuts and bolts as this, which some of the early problems do this. They just give you it directly. Or it could say, somewhere they're going to have to tell me the average standard deviation. They can't change that. But then they could say, what percentage of people would you expect to make it into Mensa? You have to realize, okay, that means the percentage of people that have a greater than 133 IQ, right?
The inequality symbol gives away.
Exactly.
Greater.
So to make it into Mensa, I have to have a greater than 133. That tells me how to draw the picture and how to go from there, right? So what percentage of people could make it into Mensa then? 1.39%. So if I wanted to start a Mensa chapter somewhere where there wasn't one yet, and there was 500,000 people that lived there, could you estimate how many people would be eligible? What would you do? If I have 500,000 people in this town that I live in, I want to set up a Mensa chapter. How many people would be eligible? What did you just tell me? What percentage of people are eligible? 1.39%. So if you have 500,000 people, how many people are eligible? 1.39% of 500,000. So 0.0139 times 500,000. Cool? It's roughly 5,000 something or other. Do you guys see what I'm saying? And then you can figure out, now that is really assuming a lot. That's assuming that this is the same across everywhere and all that kind of stuff. But still, it's a decent estimate of what to expect, right? Maybe. Yeah?
Finding, it's going to be like a stupid question, but finding percentages, you do the percentage you want divided by 100 times the number. Is that right?
Oh, so, this is 0.0139,
Right.
which we know we've come up with the percentage symbol to mean divided by 100. But to find that percentage of 500,000, you just take the decimal times 500,000. This is the true number. This is the our made-up percentage number. Just use the true number when you want to calculate something. All right, let's do one more, and then I'm going to let you guys work together on this handout that I've got. Now this is one we actually do for real. We could do a study on gas prices in San Diego. And unfortunately, I saw crude oil just went up by up to $104 a barrel. So very soon now, the freaking gas price is going to go back up again. Because it was starting to go down a little bit. I'm like, thank God. And now it's going to What?
They said it's going to go to like $5 by September.
Yay. All right, so let's say the average gas price is like $3.96. Does that sound about right? I always go to Arcos, so it's like $3.89, I think still. Well, let's say $3.96 total, average for regular gas, right? And let's say standard deviation. I'm always amazed when I see these places, they got like $4.80, and I'm like, people are actually at the pumps. I'm like, do you guys have a corporate account with these people or something, hopefully? Who would actually go here, but let's say the standard deviation is like 25 cents. Just make up something for right now. And by observation, if we plot these, we notice that they're normally distributed. Let's say that we know they're normal. Right now we have to know that, or else we can't use a chart, right? So can you figure out what's the probability that some gas station I go to in this area will have between 340 and 385. Let's say. The standard deviation is kind of big, but too bad for me. So what do you do first?
Draw a picture.
What do you do? Okay. Exactly. It should help, unless you're one of those people that put the numbers on the wrong side. Just make sure the number line makes sense, and it should help. What goes in the middle?
3.9.
And the two prices I'm interested in are actually both on this side, right? So there's like maybe 340 and there's 385. This obviously doesn't have to be perfect. I have no real idea where that should be. This is just a quick visual. And then shade in the area that you want. The people that do this, the probability of making a mistake goes down. You knew I was going to phrase it like that. So you guys, this is what I would call a classic z-score problem. It's always the same thing. You draw the picture, you make all the given numbers into what before I can look up the areas. You have to convert everything to z-scores, and then you can look up the areas. So I give people this here. They give you raw scores, gas prices, shoe sizes, heights of people, IQs. You convert those to z-scores, and then you look up the area, the percentage. So what's 340? One big mistake I see is somebody would do this. What they do wrong here? Yeah, you can't make one z-score out of two separate data points, right? This one has to become a z-score, and you have to compare it to the mean. And then this one has to become its own z-score, right? So I'll do this z-score. I did my part. Be real careful, by the way. When you put this in your calculator, if you want to put it in all at once, you've got to put parentheses around the top. Your calculator does not have eyeballs. It can't see this big division sign. If you don't put parentheses, you'll divide only this by this. Get funky, funky z-scores in. Maybe they're negative 1.24. What is it? 2.24? What do you get wrong? Oh, that's for you. So negative 2.24. And what do you get for 3.85?
Negative 0.4.
Negative 0.4?
Sure.
4.4? And make sure, I'm taking your word for it, but make sure you truly round there, right? So I'm not saying you're wrong there, I'm just saying if it was 4.47, make it 4.5, you know, that kind of thing. Don't just cut it off at 2. So when you look up negative 0.44, and this is why it's good to put the z-score with it, right? The 385 became negative 0.44. The 340 became negative 2.24. So when you look up negative 0.44, it's going to go below this guy.
0.33.
What do you get when you look up negative 0.44, son?
0.33.
Whoa, Jeff, that's the wrong. Negative 0.40, 1, 2, 3, 4. 3300. And then negative 2.24. 0, 1, 2, 3, 4. Oh, 125. So what's the area that we want? Which is also the same thing as the probability that we want. 33 minus 0.0125. Point 3175. So 32%. If these were true, I'd expect 32% of all gas stations in whatever area this is to have between 340 and 385 per gallon, right?
And what was the last step you said about that? You took both out.
Yeah, 0.33 minus 0.0125.
Down the difference.
Yes. So obviously, I mean, 0.33 goes all the way down. It doesn't stop here. If I subtract this from this, it will stop here.
One area.
Cool.
And then you subtract 5.
All right. So here is this handout.